All right, so up until now, right, I've pontificated at you for a while about how we're going to uncover deep truths about market economies and the nature of capitalism. And then we spent a lot of time diving really deep into this situation where you're haggling with some crazy old survivalist in the desert over beefaroni and water, but we haven't really been clear about what these two things have to do with each other, right? What this situation has to do with market economies. In fact, so far we haven't had prices, right? We haven't had budgets, we haven't had anything that we are used to looking at when we're thinking about people's choices in competitive markets. So what we're going to do now, right, is we're going to say, how do all of these situations we've talked about, right, situations where you and Maud are negotiating up until you reach a point where neither of you can do any better, right, where you've taken advantage of all the mutually beneficial trades, how does this compare to the situation that would arise if you and Maud essentially bought and sold beefaroni and water at some market prices that arise out of the interactions of people in an economy? In other words, what would happen if instead of just being you and Maud, there were 1,000 yous and 1,000 Mauds, you all got together in some big flea market and bought and sold water and beefaroni until market prices, competitive market prices emerged? Would we end up somewhere on our contract curve, right? Somewhere that's Pareto efficient? Would we end up somewhere inside of our core, right, inside of our negotiation space? Or would we end up somewhere like this, right? It's a big mess. So to think through this, I want to forget all about Maud for a minute and just think about what it'll look like for you personally if you're engaged in competitive market decisions, right? If you're making consumer choices given market prices, given your beefaroni and your water. So, what am I talking about? Well, anytime we've considered what a consumer is going to do in a competitive equilibrium, right? If we've got water and we've got beefaroni, all we've done, right, is we've drawn some sort of a budget constraint, and then we've drawn some sort of indifference curves. Right, and we've said that your optimal choice is something like this. Right, it's the best you can do given your budget. So if you are going into this beefaroni water flea market, right, with 700 cans of beefaroni and 50 gallons of water, we need you to do something similar to this. In other words, what you're going to do, right, is you're going to maximize your utility of water and beefaroni, subject to the constraint, right, that your water consumption times the price of water plus your beefaroni consumption times the price of beefaroni has to be less than or equal to your income. The only complication, the only thing different about this than anything else we've seen is we've got to figure out what your income is. Well, your income is just going to be the value of the beefaroni and the water that you bring into the market. What essentially what we're going to say is you'll sell all your stuff at market prices, then you'll buy your favorite combination of beefaroni and water that you can afford at those same market prices. So this will turn into, right, PW times W plus PB times B has to be less than or equal to PW times 50, right, plus PW times 700. Cool. Right, basically the value of your endowment. And what that means is, if we look at this budget constraint here, we know that one thing you can definitely afford, and just exactly afford, is to consume 700 cans of beefaroni and 50 gallons of water. Right? You could always just sell all your stuff and then buy back the exact same stuff at the same prices. So to find your optimal choice, right, we'll say that the slope of our budget constraint is just going to equal PW over PB, right? And your optimal choice if we have an interior solution, which for now we'll assume we will, right? We'll solve this just like we'd solve any other consumer optimization problem. Our optimal choice with an interior solution is just going to be where your MRS is equal to your price ratio. Right? Just like any other problem where you're not secretly involved in an endowment economy. Awesome. So you're going to end up, right, somewhere like this, where you've got a budget that goes through your initial endowment, right, with the slope equal to PW over PB. And then you're going to choose your best choice, your optimal point on this slope, right, which is going to be where your MRS is equal to the slope, right, where we've got MRS equals PW over PB. And that's great for you, right? That's nice. But what happened to Maud, right? What's Maud doing during all this time? Well, right, Maud still exists in this same economy as you. And she's still getting all the stuff that you don't get. Right, so she's also going to have a budget, right, that's also going to go through her endowment and have exactly the same prices, right? What it means that you're in a competitive economy, right, that you're in a competitive market, is that you're both, working off of common prices. So what this means is her budget is just going to be your budget from the opposite perspective, right? She can afford to buy all the stuff that you can't buy. And in fact, if we wanted to, we could draw her budget to extend like this, because of the fact that she's not aware of the fact that she's living in an endowment economy here, right? And that we'll run out of stuff if she buys over here. She's just aware of the fact that she can buy whatever she can afford with the value of 450 gallons of water, right? And 300 cans of beef Veroni. Cool. So she's going to do exactly the same thing you're going to do, right? She's going to find her optimal choice, given her indifference curves, on her budget, which just so happens to be the mirror image of your budget. Now, we know where she's going to end up on her budget. We know that because if she chose something like this, then we've got a problem. Right? If she chose something like this, then if we added up her beef Veroni and your beef Veroni, it would add up to more than 100% of the beef Veroni that exists in the world. Right, so we know, and in that case, right, if you guys are both trying to buy beef Veroni and you buy up more than all the beef Veroni that exists, the price of beef Veroni is going to have to increase, right? We're not going to be on this budget constraint anymore. So we know that if this is a competitive equilibrium, Maud's going to have to buy right here. She's going to have to buy all the stuff that you didn't buy. We also know that if this is Maud's optimal choice, right, because remember, it's not that she's doing this to be a team sport. She's buying what she wants at her prices and her endowment. So if that's her optimal choice, it has to be the case that for Maud as well, her MRS also equals the price ratio. Right? In other words, we're going to have a picture like this. Draw that terribly well. Have a picture like this, right, where her MRS also equals the price ratio. In order to have her also want to choose that out of all of the options that she can afford. So what does this mean? What this means is that in a competitive economy, right, in a competitive market equilibrium, our market equilibrium is going to be Pareto efficient, right? At our market equilibrium, we can't make you any better off without making Maud any worse off. You can't make Maud any better off without making you any worse off. In other words, after you guys leave the flea market, right, having bought the beef Veroni and water that you want at market prices, there's no way that you and Maud could come to some arrangement that would make both of you better off. So great. So we know that we're going to end up at some Pareto efficient outcome, right? We're going to end up somewhere on our contract curve. What we don't know is where exactly on our contract curve we're going to end up. So the last thing that I want to talk about is how we can calculate our competitive equilibrium given what we know. Right, so given that, as we've talked about before, your utility function with respect to water and beef Veroni is going to equal just LNW plus LNB. Right, so your MRS is just going to be V over W. Right, and Maud's going to be in the same boat. right? Her MRS is also going to be B over W, right? Just as a reminder from what we did before. So if we want to find our final competitive equilibrium, there's a couple of things that we know about this point, right? The first thing that we know is that we have MRSs equal to the price ratio, right? So what this means is that your MRS has to equal the price ratio, PW over PB, but so does Mod's MRS. Right? We also know that each of you is going to satisfy your own budget constraint. Right? So we know that for you, you're going to have PW times W plus PB times B equal to PW times 50 plus PB times 700, right? The value of your initial endowment. And we know that market's clear, right? In other words, we know that WY plus WM, right? Your consumption of water plus Mod's consumption of water has to equal 500. And then BY plus BM has to equal 1,000. Cool. So what can we do with this information? Well, as we said, right, point 1 plus point 3 tells us that we're on our contract curve. Right, which tells us that BW, or BY, sorry, your beef-roni consumption, has to equal 2 times your water consumption. Right, from that, we can say that BY over WY, right, your MRS, has to equal the price ratio, right, so 2WY over WY equals the price ratio. So that means that PW has to equal 2 PB. Awesome. So far, right, we know BY equals 2WY, we know PW equals 2 PB. From here, we can use your budget constraint, right? So we can say that PW times WY plus PB times BY has to equal PW times 50 plus PB times 700, right? I'm going to replace PW with 2PB first because there's something cool I want you to see. So I'll say 2PB WY plus PB times BY equals 2PB times 50 plus PB times 700. So the cool thing I wanted you to see here is, right, given that I have a ratio of prices, that water is twice as expensive as beef-roni, what we can see is that every part of this equation is multiplied by PB. In other words, I can just divide both sides by PB and cancel it out entirely. What this is telling us is the actual prices in our competitive equilibrium don't matter for anything. All that matters is the price ratio. And this makes sense if we think about our work understanding budget constraints. And I think the second lecture, right, where we said if we doubled all of our prices and we doubled your income, we wouldn't have any effect on the shape of your budget constraint, right, on your budget constraint. If we doubled PB here, we would essentially be doubling all of our prices and doubling our income, since our income is just the dollar value of our endowments, right, of our stuff. So we can always set one price equal to 1, right, if we don't want to have to do this work. So in this case, I can say PB equals 1. right, at no cost. And from here, right, I can use this, by equals 2wy, right, to replace all my by. So I'll say 2wy plus 2wy, right, replacing by, equals 2 times 50 plus 700, right? So wy, right, 2wy plus 2wy is 4wy, so wy is going to equal this divided by 4, right? 2 times 50 is 100, plus 700 is 800, 800 over 4, so wy is going to equal 200. From here, I can back out to get every other element of my problem. I'm just going to let you see this for a moment. Right, so I have wy equals 200. I know that by equals 2wy. So by is going to equal 400. Right, from this, I can say that if I'm consuming 200 waters, mod, right, Wm has to be 500 minus Wy, right, from our market clearing condition. So Wm is going to equal 300. Right, likewise, how much beefaroni is mod going to get? It's going to be 1,000 minus By, right, my beefaroni. So Bm is going to equal 600. And of course, my price of water equals 2 PB, which I'm just going to say equals 2, right? So my final conclusion here is that in the competitive market equilibrium, essentially, I'm going to end up with 40% of all the stuff, right? 40% of the water, 40% of the beefaroni. Mod's going to end up with 60% of the stuff, right? 60% of the water and 60% of the beefaroni. Why is that going to be the outcome that we get from this? Essentially because, given the way that we both value water and beefaroni, her endowment is worth 60% of all the stuff, right? She owned 60% of all the stuff walking in. I own 40% of all the stuff walking in, adjusting for the value of the two goods, which we get by calculating our price ratio. So if we go into the market, right, and water costs twice as much as beefaroni, we're going to walk out at a Pareto optimum, right, in a Pareto efficient quantity, where I own 200 and 400, and she owns 300 and 600. Cool. So we know that at the end of the day, right, we go from an initial endowment here to a competitive equilibrium here with market prices, right, that make this optimal for both me and for Mod, given the value of our endowments in the competitive equilibrium. The last thing that I want to leave you with is, can we know whether our competitive equilibrium, we know it's on the contract curve, do we know whether it's in the core? In other words, do we know if market interactions could ever make someone worse off than they were when they started out? And the answer here is going to be that we know that that can never happen. The reason is really straightforward, right? We know that our budget constraint includes our endowment, right? In other words, we can always afford our endowment. And so as a result, if we can afford our endowment, and the competitive equilibrium is a choice point, right? The point that we chose as our optimal choice on our budget constraint, we're never going to make an optimal choice that's worse than some other feasible choice, right? Otherwise we wouldn't have picked it. So we'll never be worse off at our competitive market equilibrium than we would be if we never traded at all. Okay, so that's all I want to throw at you today. Thank you so much for sticking with me through all this. Just a couple of last minute points here to foreshadow our big conclusions from this work that we're going to be doing the next couple lectures. When we say that the market equilibrium is efficient, right, what we're saying is that we reach a point where no one can be better off without making someone else worse off. Right? In other words, we're not leaving money on the table. We're not at some choice where there's some clearly better choice from everyone's perspective. But we're also saying, when we say that the market equilibrium is going to be in the core, we're saying that market equilibria, that competitive markets are not going to correct some sort of imbalance or injustice that comes about from the distribution of initial stuff. right? So if instead of having relatively equal initial endowments, let's say that Maud owned almost everything and you owned almost nothing, then in a competitive equilibrium, Maud would own almost everything and you would own almost nothing. Okay, thank you so much for sticking with me. I can't wait to talk to you all about this soon.